We at CS3 are glad to be co-hosting this talk through the Grand Challenges program on sustainability. This is a topic that's near and dear to my heart as someone who has studied local government decisions with respect to their environmental sustainability goals and how they make trade-offs with economic development and community development efforts. So I'm thrilled to have all of you here today and want to give a huge thank you to Maria Sanchez, the director of the Grand Challenges program here at UMBC. So we have just a wonderful lineup today. I'll shortly introduce Dr. Andrea Pierce, and we have speakers from across the university who are all focused on different dimensions of sustainability. It really is a multifaceted, multidisciplinary perspective, and we're so thrilled to have different speakers from different disciplines represented here. Before I introduce our guest speaker, Dr. Andrea Pierce, I wanted to note a few upcoming events that might be of interest to you that are hosted by CS3. They're all here in the library gallery, so that'll make it really simple. Tomorrow at 5 p.m., we're going to have Dr. John Schumacher as part of our social science forum, who will present the Lipitz Lecture on artificial intelligence and higher education. Next week, Wednesday, April 2nd, at 5 p.m. here in the library gallery, we will host our new faculty micro talks, and we'll actually have Dr. Ming Ji here presenting as well. These are an opportunity for our new faculty to highlight some of the fascinating research that they're engaged in. And then next week, Thursday, April 3rd at 4 p.m. in the library gallery, we'll have Dr. Gordon Hall, Ph.D. Emeritus from the University of Oregon, deliver a talk titled Making the Invisible Visible, Reducing Disparities via Personally Relevant Interventions. So you can find details on these events and much more at our website, socialscience.umbc.edu. We're also on LinkedIn, Blue Sky, and many other social media platforms. Also, if you are more of a podcast listener, we actually have our own podcast called Retrieving the Social Sciences, hosted by our own Dr. Ian Anson. So check that out. It's on Spotify, Apple, Amazon Music, all that. So thank you once again for being here. Please allow me to introduce Dr. Andrea Pierce. Dr. Andrea Pierce is the Director of Undergraduate Studies and Associate Professor at the University of Delaware's Biden School of Public Policy and Administration, with a joint appointment in the Department of Geography. Her research examines the intersections of urban and environmental policy, governance, land use, sustainability, and resilience. Recent projects have been funded by the Belmont Forum's Sustainable Urbanization Global Initiative and the U.S. Department of Transportation. She previously held professional positions in the Metropolitan Policy Program at the Brookings Institution, the White House Council on Environmental Quality, and the environmental law practice at Sidley Austin LLP. She holds a Ph.D. and an M.P.P. from George Washington University and a Bachelor's of Science in Natural Resources from Cornell University. Without further ado, please join me in offering a warm welcome to Dr. Andrea Pierce. Thank you.
All right, so before I start my talk, I just want to thank the team here for inviting me. I really appreciate the opportunity to engage with students in particular, so thank you for attending and for my faculty colleagues as well. Hey, good to see you. So tell me a little bit about when you hear the word sustainability, what do you care about? What do you think about when you hear that term? Anybody in the back? Over here?
Resource management.
Okay, say a little bit more.
Specifically natural resources.
Okay. What about here?
I think about 3 R's. Reduce, reuse, recycle.
Very good.
I think about neoliberalism and the extraction of resources. And the power that.
Okay. I'm not going to go quite into that depth, but I appreciate that perspective.
I think of like the rules and regulations that governments have to follow in the system.
You a policy student?
No.
No? Okay, fair. Yeah.
Capitalism and its effects on using the resources.
Resource use, yeah.
An element of hope, because like if we don't believe that we can make things last for as long as possible, then I kind of feel like what's the point of sustainability? And that's pretty much their hope.
I love it. Yeah.
I think of complex because I think it's complicated to want to achieve sustainability, especially in city or rural areas that have a high expense to meet that goal, but limited amount of money or resources to achieve that goal. That I'm stuck with. I don't know. What do we do?
Great. Over here. Anybody? Yeah.
Like a peaceful and equitable future.
Very nice. I like that. Yeah.
I think about the idea of cutting the ladder for developing countries, how developed countries tend to prioritize environmental sustainability, but then want developing countries to not do what they did to get to the first world rich part like the US.
Yeah.
Think about our planet and the harm that's being done, and then I think about greed and quality of life and the costs of sustainability, and I question, do we really want, as individuals or as societies, to make the sacrifices necessary?
All right. I'm gonna leave this here. What you've just heard is a lot of wide-ranging ideas here, right? So this gets to our first sort of question: what the hell is it that we're talking about when we talk about sustainability? Right? And it's a little bit of all of that. But part of what I want to do here, because I'm a policy scholar and a policy researcher, is sort of set the stage of thinking about sustainability from more of that policy and governance lens. So 2 words. Got to make sure I set the stage. What's public policy? When you hear the word policy, public policy, what does that mean to you?
Plans to improve or uphold social constructs.
Okay. Plans, yeah.
The laws in place that directly affect the public.
Okay. So laws and plans. All right. Anybody else on public policy?
I guess the rules to govern or how we manage public goods, public services, public things in the public domain.
Okay. Good. Yeah.
A more systematic process for decision-making of public resources.
Okay. So we're hearing policy as a noun and policy as a verb. In the back, yeah.
Do you want to go first? I would say you're identifying and addressing a public issue with a process by utilizing public resources and public opinion.
Okay.
I was going to say, like, an agreement between different policy actors to find, like, a solution to different policy issues, like, you could do, like, speed limits or other things.
Yep. Great. Okay. I want to hold that here. When I think about public policy at its most basic level, it's what we collectively do to solve the problems that we see in the world, right? And the public element there is indicating the responsibilities of governments and other public entities to engage on those problems and matters of concern, right? So the other term that I wanted to talk about briefly is governance, I said I'm going to take a policy and governance view. So what's governance? This is a more tricky one. Yeah?
Regulation and management of personnel, resources, delegation of various tasks to different people.
Okay. So a lot of people think that governance is government. It is what we do in government. So the management stuff, the personnel, the HR, the rules and regs, all of that stuff. Yep. Anybody else have a different idea of governance? Yeah? Yeah. Yeah, so a lot of what governance is doing is taking the policy ideas, what we think we want to do, and put them into practice. Yeah. But I just want to broaden your perspective out a little bit to think about governance as not just government. There's a whole literature out there that talks about governance as beyond government, that there's no way that just government can solve our problems, right? We think about sustainability and the things that you were just talking about. These are dimensions that will need to be addressed by everyone, by governments at all levels, by international institutions like the UN, by the private sector and businesses, right? By the nonprofit community and local organizations, and not least, private citizens, right? We can't get to some sort of goal of sustainability without the whole of government, the whole of society approach to it. So when I talk about governance, it's all of that. It's all of us and what we do to help address these problems. All right. Sorry. I hate talking behind a microphone. All right, so today I want to just give a brief overview of sustainability as a grand challenge. I'm going to do a little bit of diving into what is a grand challenge and how does sustainability fit, with a detour into what are policy problems, because I'm a policy person. I'm going to go through a little bit of the development of the science and the governance around sustainability, and then wrap up with a couple of thoughts, hopefully to prime the conversation that we will have with our panelists after this. Right? So that's a lot of territory to cover. It's very ambitious, so let's get started. What's a grand challenge? Grand challenge, generally speaking, is something that is big, it's complex. Somebody used the word complex, right? Big, complex, it's urgent. It's something that can't be solved by a single actor or organization, right? Dealing with grand challenges require coordinated efforts, integrated efforts, and long-term solutions, right? That's the general sense of the grand challenge. So I first became aware of this framing of grand challenges in the mid-2000s with some work that came out of the American Association for the Advancement of Science, AAAS, right? And they published this whole issue in Science on grand challenges, but what I have up here is just a section pulled from sort of the presidential address from the president of AAAS talking about grand challenges in science, tech, and policy. And he notes about how this is particularly important as something that we can rally around, right? Some idea we can get behind, some sort of goal that we can be doing our science and tech for, right? And that we can be connecting policy with that science and tech around these grand challenges, right? So as part of his initial presidential address and then in the later parts of this particular issue in Science, they went into what are some of these grand challenges, right? Not definitive, but what are some of them? And things that popped up relating to sustainability included environmental sciences, included chemical R&D for sustainability and energy security. So this is basically how do we deal with greenhouse gases and all of that kind of stuff, which I think we're going to hear more about in a little bit. And also clean drinking water and sanitation. We're high on the list of things that were talked about as grand challenges by the AAAS. Shortly after, we got the National Academy of Engineering's Grand Challenges program. So they had 14 challenges that they talked about in 4 different buckets, one of them being sustainability. And I will say, just for a point that I will pull on, a thread I will pull on later, the NAE approach was largely focused in the sustainability around energy and the environment, right? We've had other grand challenges. I won't go through them all, but my particular field, our National Academy of Public Administration, has published grand challenges in public administration. They talk about 12 challenges in 4 buckets, one bucket being ensuring environmental sustainability, and within it, they're talking about resource management and clean drinking water and sanitation. So this is sort of where we connect to for today and our sponsor for today from the Grand Challenge Scholars Program. And I pick up on the tagline here, engaging students in problems that matter, right? So I want to take this little detour into what problems matter from a policy perspective. So here's my definition from my class, from the textbook that I use in my class, right? Policy problem can be defined as a condition or situation that produces needs or dissatisfaction among people and for which relief or redress by government action is sought. Now that's just a boatload of words, right? But let's break this down. A problem is something, some condition out in the world that people find unsatisfactory, right? It's something that they want changed, and they find it unsatisfactory because it violates some sense of their values, of what they think should be the good life or the good future, right? What was your phrase that you talked about, sustainability?
Equitable and peaceful.
Equitable and peaceful future, right? Those are kind of big, big values of what we want to see for the future. And a policy problem then is this piece. We have a condition, we find it problematic, it violates some value, we want to see change, and we want our governments to get involved, right? Oh, the slide shows up funny. But a big point about policy problems is that they don't just exist out in the world and we pull them off a shelf. Problems are socially constructed, right? Part of what we did here at the very beginning was do a little exercise of what do you think about when you think about sustainability. When we think about problems, we learn about them in school and at jobs and from our parents or our friends or from the news or entertainment or whatever else, right? We are learning about these things through our lived experience. And part of that is some negotiation within society on what we think is really a problem. So that's what I mean by socially constructed problems. So these problems are perceived somewhat differently by different groups and different individuals, depending on where they are participating, what information they're getting, where they are constructing sort of their dialogue, right? And these perceptions of problems change over time. So depending on how the conditions are changing on the ground, our perceptions of what a problem may change, right? They may also change depending on shifts in our own values and our preferences, right? Are we changing sort of the goalposts of what we're trying to accomplish? And ultimately, the way we define problems and talk about problems oftentimes points us in a direction towards the preferred policy solution. So really basic example here of climate change. We can say climate change is caused by emissions of greenhouse gases. So what's our solution? Reduce emissions. Simple, straightforward problem, solution. But you take any time with any person who is working on climate change, either from a research standpoint or an advocacy standpoint, and they will list all of the reasons why just reducing emissions isn't enough, right? We need to think about whose emissions and where and when and how and why are we reducing those emissions. And at what cost? And do we have the will to do what's necessary to achieve our future, right? So in some respects, climate change is not just a problem, but it's been called a wicked problem. So the phrase wicked problem, it's emerged all over the place, but where I learned about it was from this particular article by Riddle and Weber that dates back to the 70s, where they talked about wicked problems in policy and planning, not as an evil, like not placing some sort of moral judgment on wicked problems, but as tricky and resistant to change, right? So when you see the phrase wicked problem out there, you should be thinking about something that is very difficult to influence over time. And on the right-hand side, I'm not going to read them out, but are the sort of 10 characteristics that Riddle and Weber have talked about when it comes to wicked problems. And basically, every problem is unique. Every problem can be considered as a symptom of another problem, so they're highly interconnected. And solutions are not yes and no, right or wrong. They are sort of better or worse, we can think about. So example wicked problems out there. We talked about climate change. There's various wicked problems in the environmental realm, but there's also wicked problems in a whole bunch of other areas. So I study cities, so in the urban sense, we care a lot about homelessness and housing security. We care about food security. We care about sprawl and land use. We care about the communities having a voice in their governance. We care about their resilience to climate change, a whole bunch of things, right? And we can go on and on with other sorts of wicked problems. But I'll say climate change has not just been a wicked problem, it's now been termed a super wicked problem, right? Which is, we can laugh at it a little bit around terminology, but the point being that this is not just your classic run-of-the-mill wicked problem. This is something that is overarching, overwhelming, huge, and difficult to solve. So we shouldn't get sort of scared by that, by the task in front of us. It is what it is, right? And if we care about the world, we care about society and our communities, I would argue it's our responsibility to figure out how we're going to engage, at what level and where. Because, as I said before, we will need an all-of-government, all-of-society approach to addressing this super wicked problem. And just as a side note, a good friend of mine, Guru Madhavan, he's at the National Academies of Engineering. He just published a book on wicked problems from an engineering perspective, especially systems thinking perspective, and was arguing that we need to bring these systems thinking principles into the study of wicked problems. And ultimately, he was sort of challenging traditional engineering education for its focus on highly technical aspects without this sort of civic goal in mind in many cases. I don't say every engineering program is like that, but this is a general critique of the field. And so he's arguing for us focusing more on this idea of civicware, which is engineering-informed solutions designed that are socially and politically informed, right? And are a result of civic responsibility and civic engagement. So where does sustainability fit? That was a long way around the room to get to this point. And we're talking about terms. Sustainability is a wicked problem. It's a grand challenge. Great. All right, so what is it? Our modern conception of sustainability originated in 1987 with the publication of Our Common Future, which was a report from the Brundtland Commission, or more technically known as the UN's Commission on Environment and Development. And they set out the classic definition you may have seen out there in the world of sustainable development. It's development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Simple, straightforward, fairly generic, which is good because it allows us to put some meat on the bones as we go through what is this thing of sustainable development. And they call attention, this is on first page of the report, after the table of contents. This definition contains two key concepts: the concept of needs, our needs now and future generations' needs. Right? So what exactly are those needs? Number one. And number two, that there are limitations on what we can do to address those needs. And the limitations come in part from our societal organizations and institutions. They come from limits to our ecological systems and what they can accomplish, so forth. And I'll just say the UN has served as a central function underpinning our global governance system. So this is where you get into that framing around governance, right? UN has no formal ability to control when anybody else does, right? But the UN is a source of aggregation of viewpoints. These sorts of things are commitments by individual countries on what they're going to do. And I'll just add this very last line from this later part of the Brundtland report, which suggested there's no single blueprint. Everybody needs to do their own thing. And yet, sustainable development is our global objective. Right? Okay, so we had various things coming out from this. We had Agenda 21 in 1992, which was this proclamation by the signing countries, basically with the goal to achieve sustainable development within the 21st century. Let that sit in a little bit. Achieve sustainable development within the 21st century. How are we doing? All right. This is very common in the policy world, by the way. We make big, audacious goals, and we don't meet them, but we still keep striving, because what else are we going to do? Right? So from these early foundations from the Brundtland Commission and Agenda 21, we get our really basic initial conception of sustainability. 3 dimensions: environmental, social, economic, right? Oftentimes depicted as this Venn diagram, where in the middle is this thing called sustainability or sustainable development. And then shortly after we sort of got through some of those initial conceptions, this was reframed into what we call the triple bottom line approach, or triple Ps, or 3 Ps, right, which is taking the environmental, economic, social and translating it into people, planet, profit. And from here, there was a big spin-off into the corporate social responsibility realm, as well as a variety of conversations around what does the corporate community need to do through corporate governance and their actions to help address our sustainability problems. All right, come along the year 2000, the UN puts out another report with big goals. These are the Millennium Development Goals. They had 8 of them. 1 of them specifically referenced sustainability. I'll just note that it says environmental sustainability. Just as a note, I'm going to come back to that in a bit. And I would say during the 2000s, which is when I was really getting into the research here, there was a consolidation of learning around this environmental dimension of sustainability. When people talked about sustainability, many people were talking about environmental sustainability. So it had this connection on that environmental side. But I would say a lot of us from the sustainability community recognize that's not enough. We're not going to get there without these other pillars, without these other Ps, so on and so forth. So emerged our field of what we now call sustainability science. These are folks who are doing 2 primary things: trying to understand sustainability and sustainable systems, so the science of stuff and the technology and mechanics of stuff, as well as the science that we need to achieve sustainability moving forward. So this is the research sort of for policy and governance. And there's a foundational source here from Robert Cates and others on sustainability science. It was published in 2001. Since then, there has been an accumulation of folks into the sustainability science community, right, where we're trying to share our understandings of sustainability science across disciplines, across organizations, across countries. And the big feature of sustainability science is we are problem-oriented and solution-focused, and we're drawing from multiple fields like arts and sciences, law, engineering, medicine. I would add policy and public administration, but that's my bias. A lot of times we get lumped under the social sciences piece. So we had more international summits to talk about all of this in 2002 and 2012. And we get in the 2000s into various conversations that are really problematizing how we've been thinking about sustainability, especially sustainability focused on that environmental aspect. So Julian Aguiman was one of the folks who really came out to say, what about the social? Where are we on that? That it's not enough to have environmental. We need to be thinking about the people involved, right? And he came up with this concept, which is now an alternative framing. We had the 3 pillars approach and the triple bottom line approach, and now we have this framing of just sustainability, which is defined as the need to ensure a better quality of life for all, now into the future, in a just and equitable manner, whilst living within the limits of supporting ecosystems. So Aguiman was known for bringing the equity element, bringing the social in, and bringing this focus on equity. Now, we can debate what the heck equity means, right? I have whole research papers on that, especially the project I'm doing right now. But in any case, it's something to do with how we treat people, how we collectively organize, who has power and voice, right? Has something to do with this. So there's various iterations of the science. There was some whole strand of research that evolved around this idea of resilience and resilience in sustainability science. Resilience, generally speaking, broadly speaking, right, is our ability to bounce back after some sort of shock or stressor. So we can talk about individual resilience or urban resilience for cities or national resilience for nations, right, so forth. But there's a whole lot of science and tech in this whole strand of resilience. A big takeaway, though, is that we should be thinking about our systems not just through this sort of scientific lens, but as complex adaptive systems, right? So our systems, our environmental, ecological systems, our social systems and political systems, right? They're not static. They change over time in response to what's going on. And these are all interconnected. So you have a change in one space can cause change in another space, and it makes the problem even more daunting to deal with. So the complex adaptive systems model gives us a framing for trying to extract a piece sort of the puzzle and how we're going to focus on it. But a big piece here is we need adaptive governance, right, to make things both sustainable and resilient. Sustainable and resilient. There we go. We had more science. So enter planetary boundaries, the idea that if there are certain things that the geophysical systems across the globe can provide, and they're limited. So at some point, we're going to overshoot our capacity of those systems to handle what we're asking of them, in which case that's going to trip up, not sure what that noise is, but that's going to trip us up and potentially cause what we call tipping points or other sort of dramatic shifts in how systems function. Fast forward to sort of our most recent UN 2030 agenda, where they took not only the 3 Ps and the triple bottom line and the 8 Millennium Development Goals and moved them into 5 pillars now of people, planet, prosperity instead of profit, peace, and partnership. And partnership was there with the Millennium Development Goals, by the way, but it didn't have its own pillar, right? Now, one important point about the UN, they have been clear all along that what they see as the biggest challenge is eradicating poverty, right? That poverty and the social dimension of sustainability is most central in what they're doing towards achieving sustainable development. And I would argue that I don't necessarily see that as much in the environmental realm, which I'm most familiar with. But in any case, that was the UN's perspective. So they have these 17 Sustainable Development Goals. And most recently now, we have a proclamation of the International Decade of Sciences for Sustainable Development, right? So 2024 to 2033 is supposed to be this decade where we all come together as scientists from natural science and social science and applied sciences, right, engineering, so forth, and focus our attention on dealing with complex and intricate challenges of our time. So that's where we're at for right now. So moving forward, I have a couple thoughts to tee up what we're going to talk about. Number one, there's a whole bunch of debates out there within the sustainability community. One of them, the classic one, this has been going back since the 60s and 70s when we were talking about limits to growth, so forth, is can we innovate our way out of this problem, right? Can we use technology and technological systems to get there? Or do we need to focus a lot more on our structures that we have within society, within government, within our economy, and work on that structural change piece to get towards sustainable development? It's teed up as an either or, it's not necessarily, but I'll just say that's one framing. Can we innovate, or do we need to restructure? Number one. Second, should we be pursuing this objective of growth? Growth, sustainable development implies some growth, right? We are growing as a population. We are generally growing our economies. But there's this big question about whether growth should be our aspiration. Or should we be thinking about alternatives, like green growth, the green economy, right? And even some people go so far as to question whether growth should be our goal, whether we should be seeking to retract. We have folks who are like, we need to do something now. I know we have big, complex systems, lots of moving parts, really difficult to change, and yet we got to act now. So there's those folks. And then there's other folks who are saying, yeah, but the systems are really changing. We need to be more thoughtful about where our interventions will make best impacts, right? And then there's this big debate recently over, are we overly fixated on the metrics behind sustainable development, sort of achieving the numbers that we can quantify? How many people do we bring out of poverty, right? How many people get access to clean water and sanitation? You know, all those metrics kind of stuff. Or should we be really focused more on making meaningful changes towards the kind of future that you're all talking about? Metrics be damned, kind of thing, right? So I will say there's consensus within the literature that we need interdisciplinary approaches to sustainability. No single discipline can solve this, right? We need to be working not just with the science community and within the academic community. I mean, I'm glad I have a job, thank you, UD, but my research over the past 10 years has been transferring more and more into community-based scholarship, where I'm going out into communities, talking with them about their needs, and thinking about designing solutions to their problems in place and using the knowledge, the local knowledge that they have to help solve their problems, right? So in an ideal world, we have science, we have policy, we have society and community all working together here, not just this is a problem to be solved by academics, right? And ultimately, I would argue that sort of to get where we need to go, we need not just people working now, but we need high-quality sustainability education to develop future leaders and actors that are going to work on these things, which I think is where we're sort of ending up here. There's been a little bit back and forth about how much sustainability science is truly interdisciplinary and what does that mean, and do we need to have transdisciplinary work? Don't get hung up on the terms, right? I will say one bright light I see is the development over the last 15, 20 years around sustainability transitions. So this is putting the idea of management, of adaptive governance and management front and center. How do we transition from where we're at right now to where we think we want to be? What needs to happen? Who needs to act? How do we do it? So not just thinking about the problem, the wicked problem or super wicked problem or whatever, but thinking about how do we engage sustainably towards our goal of sustainability. And ultimately, I appreciate that this literature has come back around, not just on sustainability transitions, but using this phrase, just sustainability transitions. So I talked about Agyeman's just sustainabilities, right? There's a large number of folks who are really focused on justice and fairness in this space. And that we need to not just do this to pad the pockets of various wealthy folks, corporations, all of the stuff, right? But we need to be doing this in a way that elevates all of us and brings wealth and opportunity to those who do not have it currently. Right? So with that, I'm going to stop. I know I talked over time, but thank you very much for listening.
Thank you so much, Andrea. This was very informational, and at least for me, it's refreshing to know that I'm not the only one that has trouble defining sustainability. I always thought it was that I didn't have the capacity, but it seems that it's definitely a very complex and very wicked problem. Really nice definition, or let's say way of describing sustainability. So thank you again for that. For those of you that don't know me, my name is Maria Sanchez. I'm the director of the Grand Challenges Scholars Program here at UMBC. It's one of my roles here. I'm also the director of the Engineering and Computing Education Program, as well as the interim director of the Individualized Studies Program. So all these roles are actually giving me the opportunity to have conversations like this one from different perspectives. So I'm really thankful for that freedom that I have right now to talk about these topics that are very important to me, but also because I'm having the opportunity to collaborate with people like Eric, Stocken, and all the panelists today to talk about something that is very, very important for me, personally, but also professionally. So what we're going to do right now, I'm going to start inviting some of the panelists here to the podium to start with their presentations. And then after all of them had an opportunity to talk a little bit about their work, we're going to ask them to sit on the table here, and I'm going to be asking them a lot of questions. And hopefully you would also have the opportunity to ask questions and make comments about what we're discussing. So with that, I'm going to start with Matthew Fennan. So please, if you don't mind coming up here and start with your presentation. I'm not going to say much about them because that's what they're going to be doing. So if you don't mind starting, let's me put it again. Sorry.
So I'm excited to be able to stay. I had a last-minute change. I got coverage for my kids. So can I? No, I can't. Okay. I feel torn. Thanks for having me today, and I want to thank some of my students for coming, y'all. It's really great to see you here, and the fact to want to hear me to talk even more, even a second more today. It means a lot. I work on habitat restoration and in fragmented landscapes, so that's an ecological term. And I was thinking about it for this talk. I was like, fragmented really means you dropped a pot and it's broken, right? It means broken. And I thought back to unbroken landscapes and this quote from John Muir: "In wildness lies the hope of the world." And I thought how reading about John Muir, he's such an amazing person, self-educated engineer who invented clocks from wood on his own after seeing a clock once. Just a genius, went to work in a factory, nearly lost his eyesight, decided, forget all this, I'm gonna go walk across the entire South post-Civil War, and then somehow ended up in California after a long life and was the primary push for national parks, a revolutionary way of approaching nature. So I always found him inspiring, and I thought, does that still hold for me now? What does that mean for the arc of sustainability? And how is sustainability related to what I do? I do sustainability work, but I wanted to sort of dive into it a bit. So you see here, things are a little compressed, reality. So you can see here, the reality of the world is a beautiful place, right? On the top, right? Really nice place to live. On the bottom, when we try to plant trees, sometimes it doesn't go well, but we want to live in that beautiful world. So I found floating wild on the internet, someone photoshopped the efforts of, I believe, China, right, to make this tree planting look a little more impressive, right? So that's our vision of what we wanted. What we got was the bottom left. And a lot of work goes into conserving habitats, to restoring habitats, and we think of sort of fixing this broken landscape. The rainbow makes it look pretty, but if you look closely, that's a mostly deforested tropical rainforest. It's been toasted. It's been turned into cattle production. You can actually see cattle if you squint really hard. So we look at this problem, we think, okay, so does conserving and restoring a habitat, could it solve the biodiversity crisis? Could it slow global warming? Could it improve human well-being? Could it foster hope? And the world's really interested in forest restoration, so I've just thrown up here. Evidently, the UN loves and having overlapping decades of things, which I did not know, but we're also in the UN decade for ecosystem restoration. And we're in the middle of the Bond Challenge, which is closing in a few years. And all these countries across the world have, I think so far they're at 200 million hectares volunteered by countries to be restored. So just to get perspective, that's like 2 Indias, so that's a pretty big area they're heading for. And there's things like the Great Green Wall, which is on the left-hand side that's been proposed across Africa. And there are no less than 3 different trillion trees nonprofits that want to plant 1 trillion trees across the world. And there's a host of nonprofits. 20 by 20 is a Latin American initiative where they want to restore 20 million hectares, restore or conserve 20 million hectares across Latin America. Now, a hectare for Americans is 2 football fields. Sorry, I should have said that. So just put the 2 football fields side by side, we're good. And it's gone commercial. So you see on the bottom left here, we have one card, 0 carbon footprint, the idea of carbon offsets. And if you haven't seen John Oliver's takedown of carbon offsets, I highly recommended it last week tonight. It's quite good. But all this idea is that we're going to take land and we're going to restore it. So here's a restoration plot in Madagascar. It didn't go well, right? People live in these landscapes. This is a fire that was set next door to clear some farmland, and it just jumped across into this young forest and burned it all up. And the cool thing is the person who this is their master's thesis. They actually took data on which trees survived, so some science came out of this situation. This is from my friend Leighton. So the first thing you have to ask is, given that there's people living in all these places that they're promising to restore, are all these global forest restoration pledges feasible? So I did a bit of work where I just kind of gathered together the state, looking at it about 5 years ago. And what I found is the average pledge size is about 2 million hectares. A third of the countries pledged 10% of their area, and more than a quarter of countries lost more habitat than they pledged to restore in the previous 10 years, right? So they're losing ground. El Salvador, I pick as an example here. It's 2 million hectares in size. They pledged half the country's area to restoration. So that doesn't seem feasible to you. We're on the same team. And actually, when you sort of say, okay, well, how much area have you restored in plantations? And look, that's the bottom of the x-axis here. How much area have you promised to restore? They're pretty tightly correlated. But if you look at the red countries, they're kind of off that line. They pledged to restore more area than they've ever planted. And this is in log units. This is much, much more. And if you look carefully, those countries are mostly in really poor areas. So many of them are in sub-Saharan Africa. So you think, why would countries be pledging these massive areas, El Salvador, half the country? And you could think it cynically, oh, they're just trying to like look good, right? Or you could think of it as aspirational. They're actually signaling they want help and support to these activities. And whether or not it works, no, these aren't feasible, right? Not currently. Some countries pledge more area to restoration than they have in agriculture, Rwanda, for example. But with proper support, I actually found that you could predict restoration success. So for the very few countries that have reported the restoration success, we found that just looking at how well they provided things like water and other services actually predicts how well they're going to do. So if you look at governance metrics, for example, the US, Brazil, and Costa Rica had gone beyond their pledged area. Pakistan's very close to achieving it. And then you see down here on the bottom right, places like Rwanda, El Salvador, Cameroon, and Malawi, right? They're still struggling to meet their basic needs. And it's got to make sense. If they're having trouble electrifying their country, it's going to be hard to also plant trees across the country. And is that a signal of failure or just need for more support? And I argue it needs more support. So then I got sidetracked because I thought, I looked at it, I was like, oh, most of these commitments are actually planting monoculture plantations. Like this is southern Brazil, right, today. And I thought, how much are we actually planting? I mean, they're committing to this massive new areas of planting. What's been going on? And it turns out there weren't any global high-resolution maps of tree planting when I started. And when I finished, I found that tree planting is expanding all across the tropics, right? It is the hottest new thing. Half of the recent regrowth in tree cover is planted trees in the tropics. And about, I'd say, 1/7 of that occurred in really dry areas where there had never been forests before, where you may not actually want trees because they don't belong there. And even more alarmingly, 1 in 11 protected areas in humid, accessible parks was being invaded by planting. So, and you might say, oh, that's not bad, but actually planted forests often replace natural forests. So it's kind of, we live in a world where people cut down rainforests and plant trees in their place, right? This happens all the time in Indonesia. When you're buying lawn furniture now, I was like, oh, is this acacia tree from Indonesia or Vietnam? I got to pay attention because in Vietnam, it's planted outside rainforest. Indonesia, they usually cut down the rainforest to plant them inside the rainforest. And in dry lands, this is especially true. So this is a picture from my colleague in India. And Forrest sent me this photo of a beautiful scrub thorn bush forest, very biodiverse. They bulldozed it and replaced it with a eucalyptus plantation, right? So this is very, very common. India has incredibly large goals for planting trees, and they consider drylands to be wastelands. And actually, one of my PhD students is studying that as part of her work. And it's important to take a step back and think, okay, tree planting is really annoying, right? Tree planting is, oh, it's bad. People call it green deserts. But actually, restoring forests is more than planting trees. When we talk about a forest, there are wildlife that lives in it. There are things that are in the forest like ferns, which are not trees. And there are forests, or cacti, right? And there are forests that don't necessarily look very biodiverse to our eyes, that one on the bottom right, but is quite biodiverse. They also provide a lot of services. But when you compare natural regrowth, just letting it regrow on its own, to planted, it beats it every category except for wood. And this is a cool paper that I love because they actually cited my paper as the genesis for writing their paper, which is kind of cool. It's a fun thing when you see like, oh, great, I wish we'd gotten ours in science. And wood has its place. Plantations planted outside forest provide wood, so they don't need to go into a forest to cut it down. So they save natural forest. When you replace is the problem, and that's a lot of what's going on, for example, with oil palm production all across the middle of the world and rubber production for our tires. And the cool thing is natural forests can actually stick around. They don't just disappear after people plant them. So this is a study we did in Costa Rica where we found that in the beginning we started out with a bunch of natural forest regrowth and people cut it down. They cut down a lot of it. Half of it kept going, but after 50 years, 20% of it was still sticking around. And if you look at this tiny map, a lot of those pink and blue things have been around for 50 years, and they mostly occur along streams and places where there's steep slopes. So farmers are actually letting them grow, even on highly productive coffee land. So we also, some recent work I've done in collaboration with some colleagues in Europe, has found that in general, if we know what areas are natural regrowth, which is what that previous map with plantations let us do, we can actually look at how people do economically in proximity and find that forest regrowth actually is associated with improved dietary quality and income, right? So, and actually both tree plantations and forest regrowth are positively associated with improved economic performance. There's a tighter correlation with forest regrowth, but they're both good because they bring in money and they provide new ways to get food and wood. And one of the coolest things that I've been part of is a recent paper where we actually took the kind of global data set of tree plantations, subtracted them, leaving behind all the natural stuff, and kind of figured out, okay, now that we know where all the forests are regrowing across the tropics, where could they regrow? And this is real data as opposed to a model. And it's the first paper of its kind, which was really fun. And we found that across the tropics, there's about 215 million hectares of potential area and about 23.4 gigatons of carbon. It sounds like a lot, but I always bring it down to earth. I talk to journalists, I go, that's basically a little less than 1 year of global production. Global production is about in the 30s, right? So it's, and this takes 30 years to happen as the forest regrow. So is it a silver bullet? No, it's one of maybe 20 silver bullets we need to solve climate change. But it is a really cool, easy solution because one of the fun things about the wet tropics is forests will regrow if you just walk away and keep it from burning down. So my recent research, I would say, is changing my idea about what is important, right? Wildness is important, but the hope of the world lies in re-wildness, in fixing what is broken. And recently, I've been really interested in fragmented landscapes and trying to understand them. These are landscapes where, they're often assumed to have no interesting biodiversity left. And on the left here is a 180-foot tree with a large cavity nester in the middle of it. The cavity nester is an endangered great green macaw. There are only 1,000 left in the world. And this tree has been sitting there alone on the edge of a pasture in the middle of Costa Rica for roughly 80 years since fragmentation. It's probably a 1,000-year-old tree. That tree is not supposed to be there by a lot of our expectations. A lot of work in Brazil says emergence disappear. But when I started driving around Costa Rica, I saw them everywhere. And actually, I realized I took this photo on the left when I was a kid. I was in Costa Rica. I was 20 years old. Sorry. And yeah, I was a kid. And I was so excited to see it. And I realized, actually, I never noticed it before. That's an emergent tree in the middle of the rainbow. And it occurs in this landscape, at least. Emergent trees occur at incredibly high density. In fact, the density doesn't change between forest and fragmented areas because emergents seem to be pre-adapted for disturbance and able to survive all this. And they can act as foci, for restoration, right, going forward, which is very exciting and a lot of fun. Because I think, from my perspective, sustainability is about fixing our mistakes. And thank you for your attention. That's it.
So we're going to move to our next speaker, Dr. Lee Blaney. You don't mind coming over and talk about your work?
All right, thanks for the introduction. Sorry for the pause there. I was trying to see if I could put my slide advancer in, but I think I'll figure out how to move around a little bit. But I'm very glad to be here. I'm not going to talk so much about our work in our lab here today. I'm going to set you up with some of the drivers for what we do, and then maybe some of the details will come out in the panel. If they don't, I'd invite you to talk to Sahar in the back, who's one of our group members, and she works on a lot of the problems that we're setting up here today. And so I want to start with a question. I like to ask very vague questions. What are we looking at here? What's interesting here? Any thoughts? So I'll tell you from... Oh. It is a desert.
I can move the slides if you want to walk.
I think it's okay. It's okay. Don't worry about it. Yeah. So it is a desert. Nice looking photo. You see this white line? Does that look natural? Doesn't really look natural. Does anyone know what that is? So if we zoom in and come down on the ground, it looks like this. It's actually the world's longest conveyor belt system. It's over 60 miles long, and it takes phosphate rock that's mined down here out to the coast so it can be transported around the world. That phosphate rock is really important because you all need to eat. Okay, so phosphorus is one of our key fertilizers. Most of the world's phosphorus reserves are in Morocco, almost 70% of the world's phosphorus. Okay? Our population, global population, is going up every year, which means we need to grow more food to feed those people. Right now, most of that phosphorus is there. Okay? This is a big liability. There's an economic liability. Morocco could wake up tomorrow and say, hey, phosphorus cost 1,000 times what it cost yesterday. What does the world do? It's an economic liability for the same reasons. Okay? Phosphorus, this one little element, very important. The other key element that we need to grow food is nitrogen. We produce most of the world's ammonia through the Haber-Bosch process, very engineered process, chemical engineering process. Okay? And it's actually been a remarkable aspect of the Green Revolution, being able to produce enough food for people, but it comes at a major cost. Okay? We actually spend 2% of the world's energy producing ammonia. One very simple chemical. It's only 4 atoms. Think about all the cars that we drive every day, the planes that we fly, every other chemical that gets made, every other product that gets produced. 2% of the world's energy just going to making ammonia. That also means it comes with a lot of emissions. 1.3% of global CO2 emissions just coming from ammonia production. To put that into perspective, the whole aviation industry, okay, every plane that's flying around the world every day, is 2%. And so again, just this one simple chemical really has a major impact in terms of greenhouse gas emissions. These numbers are kind of hard to wrap your mind around, okay? And so I have one more kind of unit conversion here to help you. This is equal to about 54,000 Taylor Swifts, okay? And so probably all of you have seen, news about Taylor's private jet and all of the emissions. Are there any Swifties in the audience? Okay, sorry. I'm going to make it up to you later, okay? I'm not a Taylor hater, and so we're going to make it up. Okay, and so right now, if we think about our ammonia production, there's these kind of different coatings, and so brown ammonia is ammonia that's using fossil fuels to produce that energy to make it. How can we move to green ammonia, where we're actually using renewable energy to do this, and then we can offset some of these energy and emissions, aspects. Now, I'm sure all of you have heard about nutrient pollution. Many people learn about this in high school. You learn about eutrophication and dead zones. As we discharge nutrients into a body of water, we can cause a lot of algae to grow, and when those algae die, they consume the dissolved oxygen in the water. Just like us, if the fish and the crabs don't have oxygen, they're not very happy, okay? And so that has major issues. There's 2 algal blooms that I'm showing here. The one on the top is relatively recent. I just thought it was funny. It's in California. It's a lake called Clear Lake. It's obviously not very clear. Okay, the one in the bottom is actually a very famous case from about 10 years ago now in Lake Erie. There's a major algal bloom. Sometimes when we have those, they also produce cyanobacteria that create these cyanotoxins, and they're very harmful for human health. And so Toledo actually had to shut their drinking water down for 2 or 3 days, to kind of address the situation. It's not something that we tend to think about here in the US. Oh, I can't actually drink the water coming out of my sink, okay? But this is happening, okay? It's becoming more and more common. Nutrient pollution's been an issue for a long time, but now, again, we're producing more food for more people, and that leads to more discharges. And so we should just limit those discharges, right? That means people can't eat food? I set you up, I'm sorry. Okay, I'm just trying to emphasize this is a very complex issue. We have the political, economic liabilities from phosphorus production. We have the energy implications, the climate change implications from ammonia production. We need those nutrients to grow food for people, but when we discharge them into the environment, now we have water security issues. Okay, food security is wrapped up in all of this, and so it's very complex, very wicked, maybe super wicked problem, okay? So I want to thank Dr. Pierce. She's already introduced the concept of planetary boundaries. This is coming from the Stockholm Resilience Center. You saw 3 years worth of progress, on these kind of planetary boundaries on Dr. Pierce's slide. Okay, the first ones that were really surpassed were these biogeochemical flows. Okay, and so down here you can see there's 1 bar for nitrogen, 1 bar for phosphorus. The dark purple color here means we've exceeded that planetary boundary. And as Dr. Pierce mentioned, the idea is that once we exceed that boundary, we may not be able to come back and get the planet back into balance. Okay, and so this is a big issue. These are also big numbers, just like Dr. Fagan just showed us. Okay, teragrams per year is millions of tons per year. Okay, these numbers, so the phosphorus, the nitrogen, are primarily coming from 2 places. Okay, wastewater treatment plants. Does anyone know this place? Okay, a few people. Okay, so this is in our backyard. This is Baltimore's Back River Wastewater Treatment Plant, our major wastewater treatment plant. You can see how much nutrients are coming through wastewater. These numbers are for around the world in wastewater, not just Baltimore. Okay, and then over here on the right-hand side, this is an animal feeding operation. Okay, we release a lot of nutrients from wastewater. We release a lot of nutrients from animal waste. Okay, if we think about how much nutrients are bound up in this waste, we can get back within those planetary boundaries. Okay, and so one of the questions that I think is really important here is thinking about how do we frame this question. And a lot of times, I think when I think of environmental, or when I think of sustainability, I think environmental sustainability, and I think a lot of people do. And a lot of it is like, they're the polluters. They're doing this. I don't think that opens the door to conversations. Okay, and so if I walked up to this animal feeding operation and said, you're polluting the Chesapeake Bay, let's fix it. They'll say, get the hell off my property. Okay, it's not going to help the situation, but I think we have opportunities to reframe this discussion. And so I love living in Baltimore. I love living in the Chesapeake Bay watershed because it's such a great case study for these issues. If we think about it, on the western side of the bay over here, we have a lot of urban areas, a lot of wastewater. Okay, the nutrients in that wastewater can get discharged into the bay, contribute to the dead zone that forms every year. On the eastern side of the bay, we have lots of chicken farms. I'm not ignoring Delaware here. This is just the chicken farms from Maryland. There's also plenty in Delaware. Okay, and animal waste is rich in nutrients, and again, those nutrients can run off and come into the bay. This is why we form the dead zone that you see on the map on the right-hand side. And so in the past, we maybe think about nutrient treatment, nutrient management. How do we prevent those nutrients from getting in the bay? I don't think it's good enough. Okay, I think as we're moving forward and figuring out kind of these systems level approaches of how do we weave all of these issues together, we really need to move towards what people call circular economies. I was hesitant to say that because the title of this thing is beyond buzzwords, and circular economy is a little bit of a buzzword, along with sustainability and everything else. But I think it's a really great concept because it makes sense to us. Back in the day, hey, you got something, you used it, throw it in the trash. Okay, and then we'll separate out your bottles and separate out your cans and separate out your plastics and everything else. Okay, circular economies is just recycling at the elemental scale. And so rather than discharging those nutrients into the bay, maybe we actually recover them. We turn them into high-quality fertilizers that are better than the conventional fertilizers that we use right now that tend to run off into water bodies. It's better for plant growth. And if we're able to do this here, we can generate new fertilizer economies in the Chesapeake Bay and then sell those fertilizers where they're needed. And so we're doing that work in our lab. I'm not going to get into all the chemistry and stuff like that here today, but I'm very happy if you all want to talk afterwards. Okay, and so at the end of the day, for me, and if we do this, we clean up our dead zone. I forgot about that one. Okay, so at the end of the day, if you ask me, okay, if I were to talk to the nutrient treatment or management industry, kind of our classic way of doing things right now, what would I say to them? Well, I'd say something like, look, we're never, ever, ever, ever getting back together. Like ever. Okay, so I'm happy to build off of these points, in the panel and kind of show you maybe how we approach, some of these drivers in our research for not only resource recovery, but also thinking about, other chemical contaminants in water and how we can kind of address those, in some different ways than we have in the past. Thank you.
Even here, we hear about Taylor Swift. It's crazy. I would like to invite our next speaker, Taylor Smith. Come on, please.
Thank you. And that was Taylor Smith, not Swift. But Lee, I'm still glad to hear you're not a Taylor hater. So my name's Taylor. I'm from the Office of Sustainability. I work alongside a great coordinator, Nicole Wolf. So the two of us are tasked with tackling this wicked problem or super wicked problem of sustainability at UMBC. So big job ahead of us. And I just want to take a moment and thank Maria and Eric for setting this up because we always enjoy having a platform to share our work. So first I want to just introduce the UMBC campus. The reason I do this is to highlight that we have a large student body, about 14,000 students, plus about 2,000 mixed faculty and staff, 70 buildings or 4 million square feet of space. And that gives us a great size. I actually love working at an institution that is this size because we are small enough where we still have some experimental nature to us and we can try some things and we can pilot some things. But we're also large enough that we can actually make an impact. Can people hear me okay through this? Am I speaking all right? Okay, thanks. Okay, so I'll breeze through this because Dr. Pierce was kind enough to already introduce the idea of the triple bottom line, people, planet, profit. This is kind of the classic way of looking at it as these three pillars. But I'd invite you to think about it slightly differently as a nested system. The idea being the economy, all the business that is done, that functions within society. Right? It relies on businesses following a social contract to exchange goods and services that people value. It runs on rules and regulations. And society runs off of the environment. We rely on all the natural resources. We rely on clean air, clean water. We need strong public health in order to have a good society, in order to have a strong economy. So why is that important? A couple examples. So these are both grabs from this year or late last year. LA County wildfires causing, somewhere in the neighborhood of, $200 billion, $300 billion worth of damage. 2 hurricanes in Florida, North Carolina, totaling $50 billion each. So these are, just take it a step back, these are environmental disasters causing a huge amount of social harm, causing a huge amount of economic harm. And I would argue the economic harm is even worse than that, because think about all the reconstruction of, some odd $300 billion worth of damage. That's a lot of labor and construction materials that are going to these disaster zones. And that means the stuff we buy here at UMBC, when we buy steel and concrete and other things, it gets more expensive for us too. So we are all connected. So in our office, we're trying to ask the big questions. Number one, why should UMBC act and work to become more sustainable? We've talked about this a little bit already. Sorry for some of the squished graphics here. Number two is performing a gap analysis. So what is our current performance and how far do we need to go to get there? How are we going to close that gap? And of course, the last piece, the hardest piece, is how are we going to get there? How are we going to fund it? How are we going to train people? How are we going to manage these new programs and learn new ways of doing things? I promise to breeze through this really quickly. This is a screen grab from the State of Maryland Climate Pollution Reduction Plan. So this is Maryland's vision for reducing emissions across all sectors, from electricity to transportation to waste management, from current levels down to net zero. And the state of Maryland has some projections that say, on the left-hand side of the screen, our current existing policies in the state of Maryland will lead to emissions reductions. It'll get us a good chunk of the way there. Our electricity emissions are going to drop for a variety of reasons. Our transportation emissions are going to drop for a variety of reasons. These are through, normal technological innovations, increases in efficiency, and so forth. But if we really want to get to net zero, we're going to require a variety of policy levers, and I appreciate the introduction from Dr. Pierce regarding policy and the effect it can have, because there's a variety of policies that are needed in order to push us the rest of the way there. The state of Maryland has set an ambitious goal to reach true net zero emissions by 2045. So as a state agency, we want to do our part to help us get there. And there's a story behind each one of these categories. There's specific policy levers for electricity, specific policy levers for transportation, and so forth. So this is kind of the state view, and I'll show you a little bit about UMBC's historical performance. This is between 2007 and 2023, so about a 15-year period that's pretty recent. Over that time, we've reduced all of our emissions across all scopes by about 44%. And actually, I would argue that our performance is a little bit better even than this graphic suggests, because our footprint as a campus has also grown during this time. So we have more square footage, we have more students, and nonetheless, we've been able to reduce our overall emissions by 44%, which is pretty good. But, the first 50% is pretty easy. The second 50% is an awful lot harder, because that marginal cost and that marginal effort increases with each unit that you pull out. The job gets tougher. So in our office, Nicole and I, how do we try to prioritize things that we work on? Anybody who's got an MBA loves to show a 2x2 matrix. So this is my version of an impact versus effort matrix. And the long story short is we want to spend as much time as we can on low effort or medium effort type of tasks that have the highest impact. And that impact can be emissions reductions. That impact can also be education and inspiring people to incorporate more sustainable habits in their own lives, or inspiring the university to create a sustainability component in the undergraduate degree, and so forth. So it's not all about the sort of bean counting metrics. There's other ways that we subjectively evaluate our impact as well. So I'm glad, Dr. Pierce, you introduced this idea of sort of wicked problems and systems thinking, and I think I even heard limits to growth as well. So this is a conceptual graphic from a book called Limits to Growth by Donella Meadows, who's a really impressive person who's kind of the godmother of systems thinking and addressing wicked problems. And it demonstrates that, this graphic kind of shows how do we spend most of our time. Most of us spend our time thinking about ourselves and our close family, maybe our close community, maybe nationwide. It's really hard to sort of spread the net and think more about people outside of our specific sphere. And likewise, we're often thinking about today, the next meeting, next week, maybe planning over the next couple of years. And you can hardly blame anybody because people are living through all kinds of situations. If you're struggling to put food on the table or you're balancing multiple jobs, that's really tough. And you've got to address those issues before you can, through no fault of your own, start thinking more broadly about these global wicked problems all around us. And so, our goal is to kind of help push people towards the upper right end of this graphic, and not all the time, but spend a little bit more time thinking about the world and those outside of our individual close-knit communities. And this is the only quote from Gandhi that I've got in my presentation, but we need to think about the future depends on what you do today. And so a lot of the meetings that I have, particularly in the facilities management group where I live, we're the ones keeping the lights on and planning construction and so forth. We're always having meetings to talk about, okay, if we make this decision today and we're going to put in this piece of equipment today, that equipment is still going to be there in 20 years, 30 years, 50 years. And so are we perpetuating a system, or do we need to change the way that we normally operate? So it's really trying to add that long-term perspective, which I've heard a couple people mention in their presentations. Okay, last slide here. This one got a little junky, but I want to acknowledge a couple areas of uncertainty that we deal with in our office. The first being, how do we value the sort of non-financial or fringe benefits of some of our investments? Because decision makers love to see a spreadsheet showing costs. And so I can propose a solar panel project that's going to generate a certain amount of revenue for the university every year. It's going to generate power. That means we don't need to buy power from our utility. There's a great financial benefit there. But wouldn't it be great if we had a solar canopy that provided covered parking? How much is that worth? How much is the research opportunity worth for having a solar installation on campus? How much does it help with our recruitment of prospective students who are interested in sustainability, having a nice shining example of sustainability that's very public? So there's all these non-financial things that I think are important. Lots of folks think are important, but it's kind of tough to quantify those. Second one, I won't spend too much time on this, but what are energy markets going to look like in the next 10 years, 20 years? The war in Ukraine with the Russia invasion put a new perspective on this because we saw the price of gas, skyrocket in a very short time. What do renewable energy prices and development projects do to energy prices? And then finally, back to policy changes and technological innovations. And I'm glad, Dr. Pierce, I think you mentioned this. We know that technology's come a long way. The iPhone is only 15 years old, so imagine where we're going to be 15 years from now. But can we hang our hat on that? Can we say that there's going to be a holy grail of technology that comes along that solves all our problems? Maybe, but I don't think we can necessarily count on that. So these are some of our grand challenges through our office. So I know that was very, very quick, but I'm always happy to speak with students. Feel free to get in touch with us if you are interested. It's very easy to sign up to our sustainability newsletter where we send out updates every month. And with that, I will wrap up. So thanks so much for your attention.
Thank you so much, Taylor. The next speaker, Dr. Ming Xi, is that okay if you talk here for a little bit about your research? And then we have one more speaker after that. Okay.
Hello, everyone. I'm Dr. Ming Xie. I'm an assistant professor at the Department of Emergency and Disaster Health Systems here at UMBC. So my research focuses on how communities, especially vulnerable communities such as refugees, they prepare for, respond to, and recover from disasters. I appreciate, Taylor, you mentioned about the disasters and its relationship with sustainability. So I would like to highlight a little bit about the relevance of sustainability and emergency disaster management. So as the title of the panel, so sustainability is not only a buzzword, it's not only an abstract concept, it's highly relevant to communities, to disaster resilience of different types of communities. So thinking about the different dimensions of sustainability, right? So when we talk about economic sustainability, so do you know that in 2024, the US experienced 27 weather-related disasters, each causing over $1 billion damages. So economic sustainability is not only about thinking about the economic loss, the business closures, the loss of job, and also the disruption of essential services. So thinking about Hurricane Helene happened last September, right? September? Yeah, so right now still a lot of communities in North Carolina, in that area, a lot of families, they still stay in hotels. And the children, they cannot go back to school. Thinking about the impact on each household, each community. And talking about environmental sustainability, when we talk about climate change, right? So we are seeing more and more natural disasters, unexpected natural disasters, Hurricane Helene and Hawaiian wildfire, all those kind of events. And thinking about if a disaster happens, are you ready? Do you know what you need to do? Do you know where you can get the resources? Do you have an emergency plan, evacuation plan? Do you have the emergency kit at your home? All of those things, how we can get our communities to be prepared. And also thinking about the social sustainability, I think that's always the overlooked dimension of sustainability, right? So I wanted to let us think about the winter storm we just, in Maryland, in this area, so we had a very cold or crazy winter, right? So thinking about those extreme weather events, if you are experiencing a winter storm or an extreme heat wave, you will be fine if you have the air conditioning, you have the heater, you have a safe place to stay. But not everybody has that. For a lot of people, low-income communities, elderly people, those situations could be life-threatening. And how we can develop more equitable disaster planning and to provide the services, essential services for those communities. Those are very important. So I think for me, sustainability is not only about environmental protection, economic development. It's more about survival, equity, the whole community's long-term well-being, right? It's about a community's ability to respond and recover from disasters, and how we can do that. And thinking about the various communities in our society, each community might have different way, different mindset to define what does vulnerability, resilience mean for them, and how we can get their voices being heard, and to let them define the problem and to find the solution. That might be something we need to do together. Yeah, thank you.
Right, last but not least, we have Dr. Osgur Capras, who's going to talk about the research. Now, you told me that you have your own presentations here. I hope that it works. I think, okay, you are very confident. There you go.
Okay, so I'm not going to touch this. I'm going to extend it this way for the time's sake so that we can use this effectively. I am Associate Professor at Biochemical and Environmental Engineering at the University of Maryland, Baltimore County. I moved here about 18 months ago from Oklahoma State. And our group name is Advanced Energy and Electrochemistry for Energy Lab. The short acronym is a cute name, Amy. I don't have a daughter, I have a son. If I had a daughter, I will probably name her Amy. Well, so what I'm going to talk about is actually related to my son and our future little sons and daughters. So what you are seeing here is a video I usually show when we do a K-12 activity. What you are seeing is the temperature change on the Earth, cooked by NASA since 1870s. What you see is the color gets darker and darker as the year passes. And data is only till 2015. The situation is even worse right now. And as someone who is a little toddler, I have worry about his little future, and I worry about all human beings' future, not only humans, but also animals too, and nature. What we can do? Well, we might want to think about sustainability as, do we have to rely on the resources that are going to pollute us? Or can we use our engineering and our mind to actually go back and touch the ground and be part of the circle? That means instead of using the fossil fuel, can we make it more earth-friendly? And for this one, I want to introduce you a topic called electrochemistry. If you Google US News, you might hear that actually electrochemistry is a growing field in engineering that will revolutionize the world. That's entirely reasons. Well, you are already hearing the electrical vehicles. You are using the iPhones. It is the revolution of the electrochemistry that leads us to use rechargeable lithium batteries. You might want to say lithium is very scarce, and we already have a problem in Congo. Don't worry, we have scientists who are working on problems to reduce the dependence on critical materials, but make batteries that are earth abundant and environmentally safe. So that's the topic of electrochemistry. What else? You might also think about hydrogen. It's a clean energy source to store. You can produce it when the sun is up and using electricity to use electrolysis and electrochemical technique. And when you need the energy, just convert the hydrogen back from chemical energy to electricity. Is this it? Just fuel cells and batteries? Not really. So I'm not really trying to sell you the electrochemistry to do master or PhD on it, although I have an open position. What I want to say is we can also use it to make materials. Sorry, I make this very shortly. I want to show you what I'm dreaming. I'm dreaming when I drive my car. Car is cheap enough in the United States that I don't generate CO2 gas. I have a gasoline car right now. I can't afford an electrical vehicle yet. Well, why don't we make batteries that are cheap? Maybe my car will only drive 150 miles, but I'm fine with that. Maybe it will charge in 3 hours, 4 hours. I'm coming to school. I'm fine with that. So another thing is houses. If you make batteries that are not explosive, that do not release any harmful chemicals, but also reliable and cheap, I will put solar panel on my house and start using it. But it's not right now, so maybe that's a topic we should consider. and we can power our cities with these renewable energies. Not only that, we are a creature of curiosity. We will never stop looking at the sky. That's where we start wondering, and the foundation of math, from the Egyptian times to Greek, they look at the skies in the beautiful Mediterranean Sea. That's where I'm from. And we are still looking at the future and looking at the space. And we can actually use electrochemistry to power and to make it possible for the new worlds. We can use batteries for our human health. Can we detect how much glucose in our body simultaneously? Can we detect any PFAS in my body right now? God knows how much I have since I was using a Teflon in 2010, and I think I use a scratch once too. And electrochemistry can also be used for making new materials. We can produce ammonia using electrochemistry. Haber force synthesis changed the world, but with a cost. 5% of CO2 release comes from the Haber synthesis. When our population exploded, since the ammonia production was possible with the synthetic methods, but we can change it. We still need to feed the world, but we can produce ammonia with more earth-friendly methods. We can take the CO2 back from atmosphere to the critical materials. We can also produce new materials with electrochemistry. We're not going to stop building cement. We need cement for buildings. The cement and steel are also responsible for 5% each for the CO2 release. Can we use a blue hydrogen for the high temperature steel? And can we use electrochemistry to make it cement without releasing those toxic and harmful chemicals? Yes, we can. So that is the overview of our group. And the only last slide I want to show you is, this is not that hard actually. So this is the slides we usually show to K-12 kids. When I say K-12, literally 7 years old. On the left top, what you see is eel. The animals figure out, or evolution figured out how to use electricity effectively to protect themselves. What it does is, it just transfers sodium and potassium ions through their cells. Just ion transport. And maybe our ancestors made it too, we don't know. There's a battery called Baghdad battery found in Egypt. The hierographs show that there's a snake shape with sparky. What they found is old vessels have iron and copper in them. Let me tell you a secret. Iron and copper loves to accept and release electrons. So they are a perfect couple. When you put them together and separate them with a solution that can conduct ions, and you also connect these copper and iron through external circuit. What I define here is a battery the way we know. Alexander Volta, when they were trying to figure out why the frog legs is jerking after the frog was cut for cooking, they figured out a famous experiment. They put zinc and copper on top of together. They soaked the cloths with salty water, and they made the first battery we know today. Making batteries is very easy. We make batteries with kids using fruits, Coke, anything. So what is hard is, can we make a good battery that does not pollute the earth, does not create another conflict on the earth, like petroleum? If you are going to rely on cobalt and lithium, it's going to create a political tension. And can we make them recyclable? And with that, I want to stop talking because it's a short seminar, but thank you so much for your attendance.
All right. Thank you so much. All right, so at this point, I would like to invite all the presenters to the table so we can start with some questions. Thank you. And I'm going to be over here. And I don't know, it's okay. All right, so as people settle down again, I wanted to just say that this is supposed to be a more interactive part of the event. So I'm going to be asking some questions, but if any of you want to follow up with your own questions or more clarification or want to provide some context or have opinions on the things that we're discussing here, please feel free to do so. We wanted this to be your opportunity to ask the questions and to get more engaged with these kind of conversations. So I'm going to start with the first question that I have, and then we take it from there depending on how you react to it. So I would like to ask, and do you already introduce yourselves? And thank you so much. We're missing one person. Where did Taylor go? Oh, he said he was going to the bathroom. Okay. I'm going to start without him for now. So in the presentations, you saw and heard about the United Nations World Commission on Environmental and Development from 1987. Since then, it has been considered that sustainability development requires the balanced consideration of economic, social, and environmental factors. However, we know that let's say some of them are more looked at, or some of them may be overlooked. So in your field, which one of these pillars do you think is most often overlooked, and what are the real world consequences of that neglect? And feel free to, whoever wants to answer, you are free to grab a microphone and see if it works. Yeah. No?
I'm not an engineer, so. Okay, I think it works now. So I was thinking about the MDGs, which is the Millennium Development Goals. And you may remember there were 8 of them. And what's interesting and kind of fun is that most of them have been met. Huge strides were made in terms of prosperity and well-being and even equality. 7 of them, 8, were pretty much focused on people. And it's interesting you kind of framed it as, I think in terms of policy and the way we talk about things, sustainability is making its way into the social world. They were framed as economic development goals, but now they're like, oh yeah, there really are sustainability. I think that's more of a policy discourse change, because on the ground, the sustainability goals were always focused on people. And I feel like ecological sustainability is actually the most neglected goal, because it's often lumped in with environmental sustainability. People don't see the difference between the two. But you know, there's ecological engineering and environmental engineering, and they have very different focuses. You know, environmental tends to focus more on words like natural resources. How can it help people? Do we have enough wood? Do we have enough lumber? Do we have enough crops? Whereas ecological sustainability is, are we going to keep the species around that we need for the time we need them? Are we going to support, so it kind of gets, are we going to keep the tuna in the oceans that we like to eat, the delicious tuna? How do we manage to have tuna and not kill off all the manta rays? Questions like that are really important. And I feel like that's a really underappreciated. I think also environmental justice came so late to the conversation, and we can talk about a just and sustainable world, but what does it mean to have sustainable justice? And I think that whole conversation really needs to be more developed, especially in regards to refugees and the way that our societies are going to change in response to the world buckling underneath us as it changes.
Yeah, so I love this question. I think the answer is all 3, honestly, and maybe I'll kind of bring one piece on top to start, you know, in just terms of technology. You know, we do a lot of research. We do a lot of really cool research, advance the science, advance knowledge. You know, but at the end of the day, a lot of the technologies that we're developing or the processes that we're building are not going to be economically feasible. I think there's still a role, like, for that new knowledge to guide us forward, but kind of focusing in on feasible technologies that can be economically viable. And so some of the nutrient recovery technologies that we're building in our lab, that's like the first thought. Like, is this something that could actually go out onto a farm? Is this something that you could actually recover nutrients from your pee in your toilet at home? Because most of the nutrients in wastewater come from your pee. So we deal with all kinds of fun stuff in our lab. Tell people we have the best smelling lab on campus. Just follow your nose and you'll come right to us. And so focusing on feasible technologies and not just like very elegant science, I think is important. You know, there's a space for both of them. I think in terms of the social component, like, we need to think of all parties. And you know, I tried to reference this in my talk a little bit, but you know, coming from an environmental engineering background, you know, we kind of protect the sanctity of water, air, soil, and food. That tends to be like, you're a polluter, this is a source of pollution, we got to get this out. That doesn't always open the door, you know, to sustainable solutions. And so rather than telling someone you're a polluter, figuring out, okay, well, how can we actually open a conversation with them? How can we bring them to the table to make progress together? If we're not able to do that, I think we're not going to be able to see, you know, sustainable progress. And then finally, coming to the environmental piece, I think the hardest part is it's hard to put dollars on environmental quality. And so this is where regulations come in. This is where we have to start valuing our resources more. Some of you may feel like your water bill is too high. I'm telling you, that water is cheap as dirt. You're getting your water at home for nothing. We need to put money behind the resources that are critical to people, and until we do that, we're not going to be able to see some of these sustainable technologies take over, because the de facto way of doing things is just so cheap right now. Conventional fertilizers are so cheap that working towards more sustainable ones is not going to happen unless there's some economic, kind of opportunities to come along with that.
Can I follow?
Yeah, of course.
It's okay. So I was going to ask you a question. You showed this algal bloom. So obviously algae love the nutrients. That's why they bloom. So I mean, I know that there's been some research, but I'm not fully aware of it. But recovering the algae itself for future fertilizer and other for the circular economy, how much work has been done in that, and how economically viable is that?
Yeah, so that's a great question. What I would say first is, we're not going to see the algae in the same place. And so the idea there is that you actually build, an engineered facility. Maybe it's on the back end, of your wastewater treatment plant. So kind of a coupled natural engineered system where you purposely grow the algae, and then harvest them as kind of sustainable energy source. At the same time, you're taking up the nutrients. The key here for us is right now in wastewater treatment, our wastewater treatment plants, you might not know this, many of them are energy positive. So we actually create more energy during wastewater treatment than we spend to treat wastewater, because we recover the solids. I promise you I'm not going to get too into the chemistry, but we can do some reduction and we can create biogas. We burn that biogas and we get energy back out. And so wastewater treatment plants are very sustainable right now. That's carbon. The ammonia that's in RP, the phosphorus that's in RP is going to those plants. If we recover it, we can turn it into fertilizers called struvite. Struvite is a slow-release fertilizer. And so when you put it onto a field with crops, the nutrients leach out slowly and they actually get into the plants. They don't run off right away and get into the Chesapeake Bay. And so we have these opportunities to put this stuff on the back end of our wastewater treatment plants, to do more sustainable carbon, nitrogen, and phosphorus cycling, plus many other elements that I'll stop talking and give someone else a chance. Thank you.
Anybody want to add anything, or yeah, go ahead.
Question. This is like a related topic for specifically Dr. Sheehan. So are you familiar with the shock doctrine, Naomi Klein's shock doctrine? Okay. Are you familiar with what disaster capitalism is? So it's the privatization after a natural disaster of disaster relief stuff, aid, basically, to these communities. I can feel my face getting red. So particularly, I like the example of Hurricane Irma and Maria in Puerto Rico, because these people are technically U.S., it's a U.S. territory, but policy-wise, they have no, the state doesn't fund any disaster management, and that's all been privatized. And that was all privatized after Hurricane Irma and Maria. So things like their energy grid and disaster response was completely privatized. So you had to buy that. However, these countries don't have, they have the money because they sort of have the money. There's a lot of money in these countries because there's a lot of businesses going there for tourism, whatever, tax cuts in Puerto Rico. However, the money isn't getting divested into the state and local governments, and it's not actually, the money's there, but it's not there for the people. How do you think we can shift to sustainable disaster recovery and shift from disaster capitalism, where these people aren't able to get their things, get aid, to something more, where they can get aid? And this is just a question for everybody. If it's, I know this involves a lot of different sectors, such as policy and all kinds of stuff. So if anybody wants to jump in and help, with this, that'd be pretty cool.
Yeah, thank you so much. It's a great question. Sustainable disaster relief, disaster recovery, right? So as I mentioned, I think how to mobilize the community resources to empower the community is very important.
Right.
So we've seen that. Thank you for the great examples. So we can see right now a lot of international organizations, foreign aids, very trying to help the communities that have been affected by disasters, right? But we've seen also some misuse or waste of the aids, the resources. So I think the most important part is to get the local communities prepared, right?
Yeah.
So for me, I always think disaster management, emergency management is not only the first responders' job. Everybody here, every organization, we should have the skills, knowledge, and capacity to deal with disasters.
How do you think we can fight back from, like these local communities can fight back from large multinational corporations just upending all of their, it's a big question. It's a big question.
Can I?
Can I jump in? Sorry.
Yeah.
So just to tie this back to policy solutions. So a big issue that happens with disaster capitalism, and it's not just the privatization, but it's also sort of the sort of pouncing that happens. The policy. So we have a lot of policies in the U.S. that make that really challenging. So we have Buy America rules. And so there's nothing more devastating to a community in another country if we're doing aid than we have to buy all the food here and bring it there. So anyone who produces food, right, is washed out. They can't get their livelihood back up and running. And so I think that there's like major policy solutions and that there's an advocacy piece to that. And that could create some change, and advocacy is something that communities can engage in. And so that's maybe one.
Can I actually? I know you guys have questions, but let me do something so we can generalize a little bit the conversation or expand it a little bit, because one of the questions that I did have is, in your opinion, for the panelists, and then you feel free again to follow up, and if you want to ask the question after that, that's fine. But in your opinion, what do you think is the most effective and possible overlooked actions that individuals and local groups could take to achieve sustainable goals? And that's going back to what you were saying there, is that if you were to give us a suggestion or a recommendation on what we can do as individuals or some organizations to reach some sustainable goals, what would they be? Go ahead, Taylor. Go ahead.
I'd say to encourage local economy growth and not like import everything. But
Okay.
it's also like growing your own things and not relying on other countries to just bring stuff in. That would help to include like,
Thank you. That's a good point. Taylor, you want?
Yeah, I love the comment about local economies, and I heard a couple folks earlier mention neoliberalism, corporate greed, multinational corporations, and so forth. And so this is kind of my little soapbox item. I feel that we often discourage aspiring environmentalists from going into business or economics. We kind of say, oh, that's the evil stuff over there. You know, if you like biology, if you like chemistry, go into environmental science. And I feel like we kind of do ourselves a little bit of a disservice there, because what you do is you kind of further entrench the people who are already working for those multinational corporations, have a certain way of doing things, and there's no new ideas coming in. So my bit of advice would be, like, if you have the capacity to do so, take an introductory business course, take an environmental economics course, learn about Milton Friedman and shareholder primacy and the time value of money and all these things that are really built into capitalism, because you'll be able to more effectively make the case and fight against those systems. And I think what we do is we kind of tell people, like, don't go into business, don't study business, and we put ourselves at a disadvantage by doing so.
So I started some of my earliest climate policy work around personal carbon footprints, right? And understanding sort of what do we do in our own lives that contribute to the emissions that warm the globe, right? And we then, while I was at Brookings, we then went to characterizing the carbon footprints of cities, right? To see cities are a collection of individuals and organizations and businesses and activities, right, that all are generating emissions. And so we oftentimes, when we talk about carbon footprints, we think about things like lights and cars and this kind of thing that we could do ourselves. But one of the overlooked areas that I think persists even through to today is what we consume as far as food, right? So I'm not here to evangelize going vegan, right? There's problems with a vegan diet and all sorts of things, but a lot of our food that we consume has, as we've heard about the nutrients and so forth, has been very resource intensive to produce what we're consuming, right? And so there's a good evidence to suggest that if we just decrease some of our really energy intensive food products like meat, and we eat more sort of local foods and so forth, we can start to make a dent. Now, I have a whole other project on whether local food is better than global food, and we can get into that separately. But I think food and thinking about our diets and what it is we consume and what are the impacts of those consumption patterns can have a big sort of impact more globally.
I would just to plus one that I think that becoming informed consumers more broadly is really important because, you know, what kind of banana should you eat, right? What kind of chocolate should you eat? Is grass-fed beef worth it? Is it good for the environment? These are all things that you could research, and there are places on the internet that will tell you good answers, but most people don't know. And if you know personally, are you sharing it with your family? And I think that's like part one. Like most Americans are really good at consuming it. It's our national pastime, right? But are we doing it in a way that's conscious and thoughtful? That's the first thing. And the second thing is, I think we really don't discuss enough in sustainability, and I think consider enough is the power imbalance that's evolved across the global economy. The rich have a lot, the poor have very, very little. It is a very inverted pyramid. And while capitalism is a terrible system, save for others, right? It's a bit like democracy in that regard, right? It has concentrated wealth and power. And the only real way to tame capitalism is through social enterprise. The only real way to deal with all sustainability problems is socially, right? All these solutions that people research and come up with have to be either desired by society or done through working with society. And the only real way to make that happen as an individual is to become an engaged citizen. And that is something that I think is increasingly important in today's world, to know the issues, to talk about the issues, to organize, and to talk to one's politicians. And that is critical and fundamental. And trust in government is declining across every government in the world. Steadily, year over year, trust government less and less in developed countries. And that just means that people need to step up and become better governments, to take part in government and join your school board and join as much as you can, because the more people disengage, the easier it is for the richest among us to do what they want.
I know that you had a question before. Did you want to ask it now, or did we move too fast from it?
It was about like capitalism and like disaster relief, but I was going to mention that, I mean, disasters impact capitalist endeavors too. We see that with insurance companies refusing to. It also is social, like they refuse to insure people or will have a really high price of insurance for areas that go through a lot of disasters. So Florida and like California, like they're not insuring home insurance. And no other insurance company is gonna be like, oh, I'll insure them for cheap, because they're gonna have to pay these people because it's part of insurance that you don't have to really pay for your own home being like tore down by a hurricane.
Yeah.
This kind of goes on what we were talking about, but do you think like in the future
governments may like start doing like like I can't remember the words, like relief programs to like give better like alternatives. Like how solar panels like are really expensive, but they're like objectively better in the long run. Do you think like eventually we'll get to the point where like our own government will help like the common folk, so like I can't think of the word, like pay for those fund those purchases for a better like overall quality of life? And that's a question for like everyone.
That's a really great question. Just to speak from my own expertise, a lot of these tree planting and natural forest recovery programs are funded by government incentives. So in Costa Rica, for example, there's a payment for environmental services program where they recruit landowners in different parts of the country, and they actually now have a program where they go and find the poorest parts of the country. They try to target the money there and pay them to let forestry grow or plant trees or improve their farms, depending on what the farmer wants to do. And those programs have been proliferating across the world. They're a big reason that parts of Latin America have excellent water supplies because they're protecting the watersheds above a lot of capital cities. And I think that there's a lot of hope out there. There's a lot of great stuff being done. As with their governments are going to become focused on people, I think that they need to. I think we're reaching a point in our society where, you know, for sustainability, most people would say just do one thing. You know, figure out where your stuff comes from and do one thing that means something to you, because it's overwhelming. If politics isn't for you, politics is overwhelming. But I think making the case that sustainability is connected. It's a multidisciplinary product, and it starts with lifting people up. And the biggest group that needs to be lifted up is the poor. And I think if we don't start there, then we're not going to make progress at any other front.
Right. Yeah, go
I
ahead.
think it's kind of like what I was thinking is like within like capitalism, how would you convince people that are within like the poorer class that sustainability is like actually going to help them? Because that's who sustainability would be good for. For the wealthy, I don't know if you can convince them it would be good, because when things are breaking down and they're not sustainable and you have to reproduce things, that's where profit comes into it.
Yep.
And so like when I'm just in a regular grocery store, because like I work for Coca-Cola, it's more incentivized for them to just like throw away stuff and like get rid of it. Because like you were talking about, like, should we not put as much like stuff into the water and have it go out, like make less food? Like we could make less food if we had different social systems and like giving away this food instead of just throwing it away. But again, that's not going to make profit. So how would we sell sustainability to like the wealthier class versus just everybody else? Because like I try to talk just like anybody while I'm working, and they kind of just like act like I'm like the most annoying person in the world if I ask them to recycle something. Like if they just have to walk again to the one recycle bin in the store versus throwing it away in the trash can, it's like 3 feet away because there's like 50 trash cans. They're going to get mad about it, and then they're never going to want to recycle again. Like, how do you?
Can I piggyback?
Yeah.
So there's this discourse of like Rosso's theory of development of like dependent countries and the countries that top countries, northern, southern. The northern depends on the southern, and that thing of like dependency, it shapes like how sustainability is seen in each side of the coin. So if you look at Europe and America, sustainability is like, we're like, oh yeah, we should fight for like green stuff with infrastructure and stuff, while you're looking at third world countries who, didn't finish my thought, but these countries are the ones producing the most emissions.
Yeah.
Then when you look at third world, quote unquote, third world countries, they're producing the least amount of emissions and they're fighting the hardest. Like Dr. Fagan said, they're like estimating or like pledging to like have the most regrowth or plant the most trees back, and they're doing the most, and they're also being affected the most by these issues that these first world countries are creating.
I'm going to let the panel actually talk about this. Did you have any answer of what they were talking about? Any comments on what they were saying? In terms of how do we convince the two different type of needs? The wealthiest have different needs, obviously.
So I guess I'd like to add one more thing, especially too, like when it comes to your habits of buying something. The average like concern of somebody isn't like, oh, am I spending that space? Like, how's it going to affect my children like later in life? It's like, did I enjoy this when I was a child, and is that the cheapest thing in the grocery store today? Like, that's the furthest thought they get to. And I don't, how
So maybe I can add a little bit. I don't know if I'm fully going to answer your question. I think one of the tricky things is just kind of like the hierarchies here. And so, it's the multinational corporations that own the farms, but the farmers operate on very thin profit margins. And so that pushes them, to kind of grow more, apply more fertilizer, leads to more runoff. And so it's this thing like, we want the farmer to be able to have quality of life, and be able to support their family. But by the system that's in place, the economic system from the corporations, they have to act the way they're acting right now. And so I don't know how to change that. Maybe some of my fellow panelists have. But I do want to offer maybe what I think of some of the benefit from like individual actions. So I don't usually talk about this, but I've followed a vegan diet for like 21, 22 years now. And when I started, like no one knew what vegan was. They're like, oh, are you a vegan? Like, didn't know how to say the word. There's no alternative food options, and it's still probably not a huge percentage of the population. But now you go to any grocery store and there's options. And so, I think that little bit of individual action, it can lead to some momentum. And so keep talking to your coworkers. I think we need to kind of do that to build some critical mass. And it just takes time. It's not going to be an overnight thing. And I want to offer a separate example from the developing world. And so, a lot of the research that we do and just the service that we do is like water, sanitation, and hygiene projects in developing countries. And I have one story that I love. So you mentioned Malawi. So I was doing a project in Malawi that was focused on water infrastructure and sanitation infrastructure. So basically, where did people get their water from and where did they poop? And it was so cool. Like, we're walking through cornfields in the middle of nowhere, walk up to some village, all the kids get excited because maybe they've seen a white man before, but probably not too many. And so they all run out, and this kid comes up to me. He's like, I know why you're here. Okay, why am I here? You're here to see our toilet. I was like, yeah, I'm here to see your toilet. Show me your toilet. And so they had an alternative toilet, like a composting toilet. And so it wasn't just your typical pit latrine. They took a lot of pride in that. When we talk about some of the sustainable development goals, all of them are important. But at least the last time I checked, maybe 2.5 billion people didn't have access to improved latrines. It's a huge issue, but it's not sexy. It's sexy to help people get clean water, but that water also comes out of our bodies. And so the fact that this community, this little kid, is like, you're here to see our toilet, they took so much pride in it, like it builds that little bit of momentum that then maybe, more of those toilets get installed in that community. Maybe it extends over to the next village. And so it's a long-term thing. At the end of the day, if you kind of look at the mass balance, like our individual actions don't matter. Like I'm always going to be more of a polluter than, 6 billion people around the world just because I live in this country, regardless of my diet, regardless of what car I drive. But I think we can build a little bit of that momentum to kind of exert that social force that Dr. Fagan was talking about.
Thank you. Go ahead.
Yeah, I'll add a little bit as well. I think the issues you raise are such interesting issues, and they are all wicked problems, to go back a little bit earlier. But I think it really depends on, when it comes to like a multinational corporation, for instance, back to shareholder primacy. And that company, according to Milton Friedman and, our adopted economic system, that company exists to maximize profits. Okay, quarter by quarter, every quarter, that stock price must go up. And we're reminded every day if you turn on the news and you have that little stock ticker in the bottom corner. That's what every company's focused on. Okay, so the job of the company is to maximize profits, but over what time period? Is it next quarter? Is it next year? Is it 10 years from now? Right now, we're in this short-term cycle, okay? But all the while, that underlying farmer, that farmer's land is being degraded and degraded. So if you project out, let's look 10 years down the road or even further, the decisions you're making today are not profitable decisions in the long run, okay? And trying to make that case to extend your time horizon where we're not just worried about next quarter's profits, where we're really going to squeeze our producers and degrade the underlying assets. We should be looking at it over a lifetime scenario and saying, okay, if Coca-Cola still wants to exist 150 years from now, is the way it's operating now sustainable? Is that really is the way that's operating now really the way to maximize profits over that longer time horizon? Kind of oversimplifying it, but like, I think it really just comes down to that short-term versus long-term thinking.
Thank you so much. Go ahead.
Yes, I would like to add something. So last week I attended an event about food security and food networks. So at the event, people talked a lot about, yeah, we should support locally grown food, local economy. We should go to the farmer's market. And later on, I had a conversation with my son, who is a high schooler. I asked him, would you do that to go to the farmer's market to consume more locally grown food? He said the top priority would be affordability. If he could get food cheaper in somewhere else, he would go for that. So I totally agree with you. I think sustainability could be a very neoliberal concept. So it emphasizes too much about individuals' responsibility. Yeah, we should recycle. We should consume locally grown food. And so here is the place where the policy, the institutional change should play some role, right? How we can acknowledge the existing inequities across different communities, and how we can address that. And back to our disaster management, how disasters can expose the existing weaknesses and inequities in our society, how we can address that. So like the solutions about solar panel, wastewater management, all of those, I think, yeah, we need the policies. Governmental, I'm thinking probably, yeah, in my classes, I have had a lot of conversations with my students about these kind of solutions, how those solutions could be feasible. Will the government reimburse the households to support them to adopt these solutions? Not every household, every individual can afford those solutions. Yeah, so just some random thought.
All right, I just want to pull on a couple threads that I've heard from some of the questions and some of the responses here. And that's tying this into the governance model that I talked about at the beginning, right? So we can have policy, we can have government-oriented action to try to deal with some of these inequalities, to help give people more resources, to encourage particular behaviors, and so on and so forth. But when it comes to the real capabilities to make change, that's not in government, right? That's in us as people. That's in our jobs, our communities, our organizations, our economy, and so forth, right? So these questions around capitalism are important questions, for sure, in large part because under the governance model, government can't do it. We need the resources and the knowledge of the private sector. So there's questions about privatization, right, of disaster response. There are problems with that, but governments have limited capacity too. And governments in large part need to be focused on how are they going to make sort of best use of the limited resources they have available, which is what we typically think of as efficiency, right? So, in the private sector is oftentimes focused on this thing called efficiency. And so I appreciate sort of the societal focus here and the community focus here because I think this needs to be happening at all levels, right? We need to be thinking about ourselves as private citizens and what we're doing. We need to be thinking about what our communities are doing and how they could be doing better. We need to be thinking about what our governments and their policies could be doing to do better, right? All of that ultimately will free up some resources down the line. But policymaking is hard, y'all, right? Change is hard. Motivating people or changing people's motivation and behavior oftentimes is not just giving them the rational information. If you do this, it will have this effect on the environment, right? That doesn't go very far with most people. There are some people who rationality is sort of their primary motivator. But for most of the rest of us, we're motivated by emotion, by beliefs, by ideology, by what our friends and families think, right? So we have to tap into some of those deeper belief structures and in my work, I see a big role for helping to promote civic responsibility, right? A core orientation towards public service, right? I don't think it's enough for us to rely on the capitalist structure that we have and the inherent power dynamics as they are, right? We need to be, from the beginning, thinking about what is our own personal responsibility and how do we do that? And we typically do that through a community.
Go ahead.
I was just going to follow up and say that personal responsibility is really important, but it's a common theme in environmental discourse to say, oh, you just need to reduce, reuse, and recycle. Okay, so you just shrink yourself down into a ball till you're smaller and smaller and you can't be seen on the earth at all. Or you could consume resources and make them circular, but companies make those. So you're not really in charge of how a company makes shoes. And shoes are easy to recycle if you can separate the leather upper from the rubber lower, but most companies don't invest in the glues that would make that possible. So it comes down to companies make choices, and society doesn't place regulations on companies to force them to make the correct choices. And we're essentially trapped, in a certain extent, in that system. Recycling doesn't really work. It works once. You can recycle a bottle once, and then after that point, it starts getting more and more contaminated, maybe twice if you're lucky. Yet that's told to all our children, this is the way we're going to save the world, instead of saying, why don't we get rid of single-use plastics? As an individual, you could not use single-use plastics, but we could also force the biggest producers of single-use plastics to stop producing them and use metal or glass or paper, right? We just recently went a little backward there, but it's kind of idea is that collective action is sometimes required. Individual responsibility is important, sure, but we need to also recognize that a lot of our problems today come from larger things that we can control individually. That's why public policy is so important.
And I'm going to add a little bit here is educating the student, educating the future generations on think about this, or having these considerations from the beginning, not as users, but as producers of technology and producers of policies, as producers of whatever they're going to be producing. They need to have these considerations in mind. With that, I would like to ask one final question, and it is, what gives you hope in your line of work? So what is the thing that you have seen certain advancement on towards a more sustainable goal? And what gives you hope for the future?
Can I start off? We just go down.
Sure.
Okay. To answer your question, sustainability can be quite cheap. That's a great selling point. Planting trees is more expensive than letting forests regrow, and both of them are way more expensive than a lot of other options for combating climate change. The price of solar and wind electricity has fallen so dramatically during the last 20 years that it's now cheaper than oil or coal on a cost-competitive basis without subsidies. We are going into this brand new world of alternative energy, of people taking actions for the environment because they make financial sense. So if we just all stopped with all policy, wind and solar would win. And that's really wonderful. We're now in a world where, population growth is slowing down. Why? People want to educate their children. The virtuous circle is winning. The projections that I faced as a young man were very dire, and we've now already moved, most likely, away from the worst possible world we could have ended up with. Global warming, the high-end projection, is considered increasingly unlikely. We're going to get to a warm world, but it's going to be less warm than we could have been. That's really encouraging and exciting to see the efforts of the world bearing fruit, and also just to see technology kind of winning the day.
Yeah, it's a great question. I think maybe I'll build off of my previous comments a little bit here. So we deal with a lot of different chemical contaminants in water and wastewater in our lab, not just nutrients. And so one of the other major classes that we deal with is antibiotics. And you might not think about antibiotics as pollution, okay? But everything that you put in your body, you pee out. And so it goes down the toilet, goes to the wastewater treatment plant, goes in the environment, okay? Probably you've heard of superbugs, antimicrobial resistance. This is, I think, like the #1 public health challenge of this century. There's projections that our antibiotics are not going to work, starting in the 22nd century. And so how do we treat infections if antibiotics don't work? There's not an answer to that question right now. In this country, we send about 70% of our antibiotics into animals, and it's not to treat infections. is to make them grow bigger, fatter, faster. And so it's just kind of a economic, idea. But the economics of antimicrobial resistance are also staggering. I think, if I have my numbers correct, maybe we spend something like $35 billion a year on antimicrobial resistance right now. In 2050, it's going to be the #1 cause of death in this country, so we're going to be spending even more. And so thinking about, okay, how can we start moving away from antibiotics in agriculture? Other countries are doing it. A lot of Scandinavian countries, Japan, countries around the world. And so there's a global effort to kind of stem the development of antimicrobial resistance. Some of you may have water bottles that say BPA free. BPA is bisphenol A. It's an endocrine disruptor. It's a plasticizer, so it helps when you drop your bottle. It doesn't just break into 1,000 pieces. Because of consumer pressure, BPA was phased out of a lot of plastics. Now, to be fair, other BP molecules were inserted in instead, but I'm given hope by the fact that now consumers have access to a lot more information and they can exert pressure to change out some of these chemicals that we're using. Another example that's a big one, and Dr. Chapraz mentioned it earlier, is PFAS, forever chemicals. Okay, this is something that's relatively new, in the field. It was really in the late 90s that people started looking at these molecules and water and their health effects. And just last year, less than 12 months ago, the EPA instituted new maximum contaminant levels, to limit PFAS concentrations in your drinking water. And so we're making progress, on drinking water regulations, wastewater regulations, the use of chemicals, in different industries at a faster pace than we ever have. I think it can be faster. I want it to be faster. It needs to be faster. But I'm encouraged by that because I think we're gaining momentum, which means then we can start pursuing green chemistry. How do we make molecules that degrade faster in the environment and don't have these toxic effects, but still have the same properties that we need in our shoes, our food, and everything else that we use every day? So that gives me hope.
Yeah, I think for me, hope is from education and community empowerment. Still back to emergency management. So, we always use the term natural disasters, right? So we are all familiar with that term. But recently there has been a big discussion about there is no natural disasters. Do you know what does that mean? It's not only about man-made disasters, it's also about, even if the floods, the hurricane, they affect different communities differently. So it's still about how to acknowledge the existing inequities, how some vulnerable communities, they are disproportionately impacted by disasters. Some vulnerable communities, they don't have choice they don't have the option or means to evacuate before the hurricane, right? They might not have the transportation. And how can we help them? That kind of thing, right? So although we talk about, the floods affect the whole area, actually people might have different capacities, different levels of capacity to deal with that. So the acknowledgement, the awareness is very important. Yeah, so that's very important. Another thing I also wanted to add is about the role of technology. So recently we have discussed the use of AI for disaster risk reduction. But I think it's more important for us to be aware of the existing gap in the technology affordance, right? Will that gap be widened with the new advancement of technology? And how can we do something to address that? Yeah.
So speaking about Maryland specifically, I'm very optimistic that Maryland has strong policy in place that will continue to make progress. So just in the last couple of years, Maryland passed the Climate Solutions Now Act, which formally set a statewide goal to reach net zero statewide emissions by 2045. And just this past December, they adopted a new building energy performance standard intended to phase out fossil fuel use in large buildings by 2040. So both of those are on the books, and over the past year or so, I've never seen more activity among our facilities management and leadership groups at UMBC, and I'm led to believe other institutions around the state are treating it with the same level of urgency. So I think that we have some policies, despite what may happen at the federal level, we have some policies in the state that have really set us up for success.
Just to piggyback on that, right now in the U.S., the place to be on policy and governance is state and local, right? At some point, it will come back at the federal level, but I'm telling my students, especially now, that state and local is sort of where they're most likely to make change. So my students are what give me the most hope moving forward, right? My students are aware. They are engaged. They are willing to challenge the status quo and the power dynamics that are out there, right? They have a sense of personal civic responsibility and an interest in collective action, as we've heard about, right? So I have hope because I see the next generation and their commitment to addressing this problem. Do I know how to solve it? No. But do I believe that the next generation can? Yes, right? So that's ultimately where I'm at with, and why I like to be an educator and why I like to interact with students, whether you're in the university setting or lifelong learners, right? Those of us who are already in faculty, staff, other positions, right? The students give us hope.
Well, just to end this, for me, the hope is into two categories. The one of them goes to scientists. I have not met any scientists that have a heart to hurt. All of them are working with curiosity to help. And those are great minds that are doing the real magic. If I tell you some of them, do you know you can extract uranium from seawater? There are, for every 3 billion molecules in seawater, 3 molecules are uranium. And yet, yes, scientists are working on effectively separate these so we can use maybe a local reactors. I know that's just this one example where I have been amazed with the topics and excitement scientists have. And that shows the importance of science needs to be funded by public, not the private entity. And second, I have a hope to the category of the K7. Anytime I do outreach, those young minds that are unshaped yet, they are understanding and acting on it. So that means, I just want to give one example. When I was in Oklahoma, I was doing a grandparents' university that I was educating batteries and environments to the grandkids and their grandparents. I often see grandparents struggling to hearing the problem with petroleum, being in Oklahoma. They grow up there. But grandkids understanding the problem and discussing with grandparents how they should take action. 8, 7, 9 years old kids, after experiencing making lemon butter by themselves and hearing the consequences, those are the minds that we need to protect and we do need to inform. And those are the two categories makes me hopeful. Thank you.
Thank you. I wanted to say thank you to the panelists so much. Just let's give them a round of applause for that. I appreciate your time. We had covered a lot of.
Oh, okay. Yeah.
I know. Oscar was very kind of staying here, even though we need to go. So what I wanted to say is that we had covered a lot of topics here, and I really appreciate your questions. I appreciate your time for this conversation. But one thing that we can definitely agree on is that sustainability is complex, and it requires everybody to work towards a more sustainable future to make a dent on this wicked problem. I wanted to say that this is not a solution that can come from a particular group of people. It has to come from all of us working together towards those solutions. And for the students, I would like to offer, if you allow me, just offer a suggestion. Try to engage in more conversation like this one. Don't stop today. Let's move forward and having more and more of these conversations with everybody around you, your professors, your peers, your families, friends, and so on. And another last suggestion is think about the Grand Challenges Scholars Program. So in that program, we do talk about these issues often, and it's a way for you to find others that have similar thinking on these topics and to find solutions for grand challenges. I do have a slide, so close your eyes because I think it's going to be on your eyes. But very quickly, just to give you opportunity for the students to see, a little bit about the Grand Challenge. I'm not going to go through the slides much. I just wanted to leave you with a QR code for an application and another one for the website. So if you have a chance to check it out, this is the application form, and this one is the one for our website. So if you want to learn more about the program, don't hesitate to talk to me. I think you can find my information there, or if you want to talk to me right now, I'm available. Thank you again for your time. Thank you again to the panelists. I really appreciate this. And like I said, let's hope that this is one of many, many, many conversations about this topic. All right, thank you again.